this is Jesse Rogers, and this is the second factoring video in the series. And we're going to build on a concept that we had in the previous example, which is factoring out terms that are in common. So this is actually we're going to skip case 2 or situation 2 here for now, and we're just going to jump down to 3 where it says check for factor by grouping. This is actually going to be a factor by grouping problem, and you can notice factor by grouping problems, they usually have 4 terms. They often have 4 terms, or they can easily be arranged into having 4 terms. And so what we're going to do is actually group these together where we notice that these two have a common factor, and we notice that these two have a common factor. So we're going to treat it almost like 2 separate problems at first. And so when we try to factor out what the first 2 terms have in common, what are their factors? That's going to be 7a in each one of those. And this is 7a times a plus 7a times 2. Right? So if we break the factors down a little bit further, 7a squared, that's 7a times a. And 14a, that's the same thing as 7a times 2. So when we divide each of these by the common factor, which is 7a, when we divide each of those by 7a, those can cancel, those can cancel. Now, why do those cancel, by the way? 7 divided by 7, anything divided by itself is equal to 1, because 7 goes into 7 one time. So we say that it cancels because 1 times anything, in this case 1 times a, is just going to be a. So it doesn't really have any impact on it. We just bring down the a here, and we bring down the 2, because the 7a is canceled out. So we can prove that this is right by multiplying it back. 7a times a gives us 7a squared, plus 7a times 2 gives us 14a. So that's true. Now let's move on to the other piece of this, which was 6a plus 12. What does 6a plus 12 have in common? What's the largest factor that they both have in common? Well, we see that they're both even, right? So they're both divisible by 2. We can always start with that. But they actually have more in common than that. 6a is divisible by 6, and 12 is also divisible by 6. So if we factor out a 6, what that's going to leave us with is 6a divided by 6 is a. 12 divided by 6 is 2, and they're separated by a plus sign. All right, so now we have a factor by grouping problem where we've taken the first step, which is to factor out of the first set of terms and factor out of the second set of terms. Now, it's not always necessarily going to be lined up in an order that's going to allow us to do this. We may have to rearrange the terms in order to make this possible, so do keep that in mind. But now, what I want you to see is that this a plus 2 piece and this a plus 2 piece are exactly the same. So what we're going to do is we're just going to do one layer deeper than we did before. We're taking that same piece, this a plus 2, and let's call it a heart. we'll say a plus 2 is represented by heart. Okay, so we're going to take that. This is really like 7a heart plus 6 heart. So they have heart in common, right? So what we're going to do is we're going to take that heart and we're going to put it out front, just like we did with the 7a or the 6 earlier. So we're going to take what they have in common and put it out front. And this is going to be what's left over. So it's going to be 7a plus 6 that's left over. Now, of course, heart, that was our own invention here. So what is heart? What is it represented by? That's really a plus 2, right? That's an a plus 2. So this is the factorization. And we know that we're done because a and 2 don't have any common factors, and 7a plus 6 don't have any common factors. So there's nothing further that can be factored out. So this is the complete factorization. And so we've actually got this problem now finished. So that is factor by grouping, and that was the third item in our checklist here, was the factor by grouping. The reason why I put that for number 3 is because it's actually a little bit harder than to notice than the difference of squares of the perfect square trinomial, but it's easier to explain. So I will next talk about difference of squares and perfect square trinomials in our next video. So like and subscribe, make sure that you get these updates.